Right. I have a unusual way of answering this question. It's not the best way of answering in terms of efficiency, but it's just worth. It's nice just to see where our brains work. Okay. It says there are 4 isomeric alcohols with the molecular formula C4H10 OH. Now, 2 of these are butan-1-ol, butan-2-ol. The other 2 isomers are alcohol X and Y. Draw the displayed formula of butan-2-ol. Okay, alcohol X does not react with acidified potassium dichromate. And name the 4th isomer, alcohol Y. When I look at this, the kind of thing I think about is, from the name and also from the formula, you see, if this was butane, it would be C4H10. I know it's not really relevant for this question, but I kind of look at the basic structure first. And they have given the name, so what I think about is, I've got 1, 2, 3, 4 carbon atoms in butane. And what my possible structural isomers? Well, I've got that, and the only other thing I've got is these. Well, I can't have any other structural formulas. So butan-1-ol, well, that's nice and easy. You've got an OH on your first carbon. This is butan-2-ol, so the only place we can have an OH is either here or here. It doesn't matter about the other two because it's just the same thing flipped over. So butan-1-ol would be an OH there. But you see, it didn't ask for butan-1-ol, it already given me butan-1-ol. So what I'm going to do is, let me rub that out nicely. I'm going to put my OH group, my alcohol functional group, on this carbon atom here. And just for them, I'm going to drop in all my hydrogens, just like this. Okay, as I said, it doesn't matter which side you put it on, as long as it's the second carbon. And here I've numbered it 1, 2, 3, 4. I could have gone the other way. So now we get to the interesting thing. This structural isomer here. Okay, so I've got a choice. OH here. My second choice, I'm just going to draw it very quickly, is OH there. So, which one's which? Alcohol X does not react with acidified potassium dichromate. You see, acidified potassium dichromate will change an alcohol to an aldehyde or a ketone. The problem is these tertiary alcohols won't. So this is X. And the reason it won't is because if I suddenly take, we'll see that make it clear, if I suddenly take this alcohol here, this tertiary alcohol, and try to put, let me just draw it under here, carbon, 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 change to a ketone, well, I'm kind of messed up because I've got 1, 2, 3, 4, 5 bonds around my carbon. So this must be alcohol X because it doesn't react with acidified potassium dichromate, and this must be Y. So now what I've got to do is name Y. And so, where am I going to start from? Well, I want to start from here. The reason being, and where I'm going to name Y, there are no functional groups on the carbon atom I've put a 3 on. So let's name this. So in terms of the first functional group, I can see the OH. This is going to be, and it's butan. 1, 2, 3, propan, and I've got to be careful, it's my first carbon, propan-1-ol. It's not butan, it's propan. This carbon here is no longer part of the main backbone. It's a methyl group. So we're going to have 2, second carbon here, 2 methyl propan-1-ol. I was a little bit scruffy at the end, but I hope that made sense.